So you can see there are 2 oxygen from the carbon dioxide and then 1 oxygen from the water. And that's how you get the 3 together. Do you have a question?
Yes, okay. I got that part. It's just the part about balancing out numbers in front of the molecules.
Okay. So is that kind of like, how would we go about making them even?
Yes.
Okay. Yeah, we'll do that with this one. And then we'll do one that's a little more difficult after this.
Okay.
All right. So for this one, I see the carbon's already balanced. My hydrogen, I have 4 on the left and 2 on the right. If I look at the water, the formula for water is H2O. And what that says is I have 2 hydrogen atoms and one oxygen atom. So that's per water molecule. So if I want to make more oxygen, I have to put a coefficient in front of it. So I have to multiply something by the subscript, which is 2, in order to get 4. So that would be 2. So then I would have 2 H2O plus CO2. So at this point, I make sure that I count again. And I don't have to count both sides because I only did something on the right. So I've just got to count the right again. Still 1 carbon. Now we have 4 hydrogen and we have 4 oxygen. So to figure out with the oxygen, we have this oxygen here and this oxygen here. So let's see, let me change colors. So you're going to take this 2 and multiply it by the subscript of oxygen there. And there's no subscript, so I assume that's a 1. So that means that we're going to have 2 oxygen. And then when I'm counting the hydrogen, it's the 2 times the 2 for the hydrogen. And that will give me 4. So with the oxygen, there are 2 from water and then 2 from carbon dioxide, and that's what gives me 4 over there. And so the carbon is balanced. So we're kind of done with these numbers. The carbon is balanced, the hydrogen is balanced, but now the oxygen's not. So we're going to put a 2 over here so that this 2 times this 2 makes 4. And then everything else stayed the same because we didn't put anything in front of CH4. And so now at this point, it's balanced. Any questions about this piece right here?
No, I get it. So at the end, both sides, both the reactive side and the product side, have to have the same numbers?
Correct. Okay. Yes. And that's just, we're just showing we didn't make carbon out of nothing, or that we didn't destroy any carbon.
Okay.
So even though the methane burns, it becomes something else. And when I say destroy, that would mean like to obliterate and make no longer exist. Mm-hmm. So obviously it still has to exist. It'll just exist in a, it'll be in carbon dioxide instead of methane or something like that.
Okay.
All right. Does anybody else have a question?
Thank you.
You're welcome. Let's see. Elvin? Anybody? No? You have a question about the fraction. Okay. Yeah, we could do that one because Corley wanted to do one that was a little more complicated. That's a really good example. Do you have a specific question about the fraction one?
Can you hear me, Professor Kelly?
Absolutely, yes.
Okay, so in class, we went over that fraction problem where you said, I think you're supposed to like divide it like by 2. Are we supposed to like divide it by like 2 based on like the whatever it was shown here, or is it like in general we divide it by 2?
Give me 1 second. Let me pull that question back up.
Okay.
So that because I have the worst habit of like, I think I remember it. I'll remember it completely wrong.
Okay.
And I'll be sitting here trying to balance something impossible for an hour.
Okay.
All right, let's see. And these notes that I went over today, just in case you want to look at them, are under exam materials. Then you go to exam 4 materials. Then you go to study resources and click on alternate notes. And they are the second set of notes. And let me get down to that one question. Okay, so it's C4H10 and O2. All right. So there it is. Okay. I'll put it here. C4H10 plus O2 makes H2O plus CO2. All right. So again, we're going to do, I don't know why I deleted my carbon there. Okay. We're going to count up the carbon, the hydrogen, and the oxygen. And then the goal in the end is to balance them on both sides so that they equal the same thing. So same number of carbons on the left and same number of carbons on the right. So right now, really? Okay. My Zoom is the cheap version that I don't pay for. So it gives you 40 minutes for free. So if in about 10 minutes the meeting just shuts off, you can go back to the classroom and log back onto the office hours, and I'll log back onto the office hours and we can finish them out from there. So if you just notice it disappears, that's why.
Okay.
It's giving me that 10-minute warning thing. I should be able to get this done in 10 minutes though. Okay, so let's see. Okay, so on the left, we have 4 carbon, 10 hydrogen, and 2 oxygen. And on the right, we have 1 carbon and 2 hydrogen and 3 oxygen. All right, so I'm going to start with the carbon and try to make sure there are the same number on both sides. So on the left we have 4, on the right we have 1. So I'm going to put the number, let me change colors from that. Okay, I'm going to put the number 4 in front of this carbon here. That way I'll have 4 carbon. Now it also changes the number of oxygen because it's telling me I have 4 CO2s. So that'll change a little bit. So I'm going to recount everything on this side. So now on this side I have 4 carbon. And I still have 2 hydrogen because I didn't change that. And then I have 4 times 2 oxygen. So that's from the carbon dioxide part. So what I'm doing is I'm taking this 4 and multiplying by this 2. And that's going to give me 8. And then to it, I'm going to add this oxygen. And so that's going to be a total of 9. All right. And then we're done with these. So now we want to look and see what else there is that that we need to balance. So the carbon is good. When we get down to the hydrogen, we've got 10 on the left and 2 on the right. So what I'm going to do is I'm going to change the number in front of the water, because that's where the hydrogen is on the right-hand side, to a 5. So I'm going to take the 5 and I multiply it by that 2 there, and that's going to give me 10 hydrogen. And then if I look at the carbon, I still have 4 carbon. And the oxygen, now I have 8 oxygen from carbon dioxide and 5 oxygen from the water. So that's going to be 13 oxygen. So the carbon matches and the hydrogen matches, but the oxygen is off. And the problem with the oxygen is that with this 2 there, there's nothing I can multiply it by that's a whole number that's going to give me anything that isn't even. So I can multiply an odd number, which would be 1. 1 times 2, that's 2, or 3. 3 times 2 is 6. Or I could try even numbers like 24. 24 times 2 would be 48. Or 13 times 2 is 26, or something like that. So I have to temporarily use a fraction so that I can get 13, because I have 13 oxygen on the right-hand side, but only 2 on the left. So the trick to that is to take the subscript for the oxygen on the left, which is a 2, and take the number of oxygen on the right, which is 13, and just turn those into a fraction like this. And that's the number that I'm going to put right there. So let me see if I can fit it in here, maybe. I don't think I can do it like that. Okay, just do it this way. And the reason I do that is if you take the subscript of the oxygen on the left and you put it on the bottom, then when you put it over here as a coefficient, it has to be multiplied by the 2 that's the subscript of the oxygen when you're counting up the oxygen.
Mm-hmm.
And those 2's will cancel when you multiply them. And then the final answer is 13. But now we have a new problem. So what do you think the new problem is?
Is it that 13?
It is the 13. The 13 is the biggest issue because on the right, 13 is a whole number. So that's okay. But on the left, we had to do 13 over 2 in order for them both to be 13. And 13 over 2 is a fraction, so that doesn't work anymore. So we have to get rid of the fraction. So let me put these in here. Just recount it real quick. Okay, so how do you think we get rid of that fraction?
Do we divide it? I'm not sure.
That's a good guess.
Okay.
So this is what we'll do. So let's say you have 13 over x equals 1. One thing you can do to get the x out of the bottom here, to get the x to cancel, would be to multiply it by x. And then that would cancel. And so that causes the fraction to kind of disappear. So the same as if I had 1/4 and I want the 4 to cancel, I would just multiply the whole thing by 4. But the thing is, I can't just multiply one piece. Like, I can't just decide that I'm going to multiply just this by like 72 or something. Whatever I multiply one coefficient by, I have to multiply all the coefficients by that. So if I'm going to multiply the coefficient by 2, then I have to multiply them all by 2. And the first one doesn't have a coefficient, but that's just like if I had C, then we assume that the subscript would be 1. Or if I had written X, we assume that the coefficient of X is 1. We just don't write it there. I think it's going to shut me off in like 30 seconds. So I'm going to log off and then start a new Zoom in just a second. So it'll shut off for a minute, but go back to the class, click on virtual office.